A very good morning to one and all. Today concept is about removal of null productions, and this is one of the way that we need to simplify the context free grammars. And as I already said in the last class, we're having three ways of removing or reducing the context free grammars. In that, the first one is removing useless symbols, and the second one is removing or reducing the unit productions, or the third one is removing of null productions, right? So here in the removal of null productions, in the concept of the removal of null productions, here in a context free grammar, if a non-terminal symbol, that means if you know the syntax of the production means, then you can easily understand how to remove or how to reduce a null productions. Wherever if you see the production with an epsilon, that means if we are having a production like this, a tends to epsilon, then you need to eliminate this, right? You need to eliminate this null productions. Epsilon is a null production. And here for eliminating the null productions, directly we can't eliminate that. Directly just by erasing the a tends to epsilon, we can't eliminate that, or we can't simplify that, right? So we're having the procedure to follow, and here we're having three steps of procedure to follow this elimination or to follow this removal of the null productions. And here, and what the thing is, in a context free grammar, if you are having a non-terminal symbol like an a, where a is a nullable variable, that means if you are having the production with an a like this, a tends to epsilon, or there is a derivation that starts at a and finally ends up with epsilon, then we can say that those are comes under the null productions. And for removing these null productions, we are having some steps to be followed. In those steps, the first step is, first we need to find out the nullable non-terminal variables where those variables should derive with an epsilons. Otherwise, if a variable does not derive with an epsilon, means no need to touch those variables. No need of touching those variables. Only if you need to touch the variables with an epsilons, right? And step number two is, for each production, a tends to small a, where it is in production, right? So you need to construct all the productions a tends to x, where x is obtained from a, and just by removing one or multiple non-terminals from step one. What it means is, if you are having the production with an a, where the production with an a consisting of more than two rules, in those two rules, one rule with an terminal and another rule with an epsilon, then what you need to do is you need to remove the variable a, right? So from where it is deriving, and that means from the starting of the variable that we are deriving an a, or else or somewhere else, you need to check it out those, and then after checking that, you need to substitute the rules of the a in that, and then you need to eliminate, right? So then what the step 3 is, you need to combine the original productions with the result of step 2. That means here we did an reduction, right? In the step 2 we did some reduction, and with that reduction, what the original grammar is there, from the grammar you need to write some productions along with this reduced production. Then finally you can say that it is a modified grammar g dash by removing the epsilon productions. And these are the three steps you need to follow when you are removing the null productions. Directly you can't take the epsilon, directly you can't remove the epsilon, or directly you can't eliminate the epsilon. And what's the process of eliminating this epsilon means, somewhere you need to substitute the terminals or non-terminals of that variable, then only you can eliminate that variable a. Otherwise, you can't eliminate that variable a. Directly can't take that a tends to epsilon. Directly can't eliminate that a tends to epsilon. Is it in? Is it it? I think you all understand what I'm saying to you all. And from, if you are having the epsilon production, means if you are having the epsilon production with an variable, some variable like an a, means you first of all you need to check it out what the other rules for the a is. No, along with the epsilon rule, you need to check it out what other rules for the a is. Then what you need to do is you need to substitute in other productions where a is there. In the place of a variable, you need to substitute what the a is deriving here, and then after that you need to eliminate that production. Up to that you need not eliminate that production, right? So this is the steps. These are the steps that we're having for eliminating the null productions. And then here we're having an example for removal procedure, and with this three steps, here it is an example. Now let's see how it was implemented with these three steps. First, you need to check it out what the given grammar is. Here it is a given grammar. S tends to ASA or AB or B. S is having three rules: ASA, AB or B. A is having one rule: A tends to B. B tends to B or epsilon, right? And here only what the thing that we're doing is we're removing the nullable variables, right? We're removing nullable variables. So coming to the solution, you need to check it out where and where we're having the nullable variables. So there are two nullable variables, A and B. Why A and B means A is deriving an B and B is deriving an epsilon. Actually, if you substitute epsilon in the place of this B, then A is also deriving an epsilon, right? So that's why we're taking that there are two nullable variables. A and B are the two nullable variables. At first, we will remove B tends to epsilon. We need to remove this B tends to epsilon. Then after removing this B tends to epsilon, then the productions of the set becomes, and how I am removing this B tends to epsilon means wherever I am having the B, there I am substituting epsilon. Now see, in this rule I am having in what the rules that the production of the variable of S is deriving, three rules I am having. In those three rules I am having B here. If I substitute epsilon in the place of this B, now I am getting A as an another rule, right? So then I need to take as A, take it as an A. And B tends to B is remain. B tends to epsilon that we are eliminating, right? And A tends to B in the place of this B. If I put an epsilon means I can remove this A also. So after removing this B tends to epsilon, the production of the set becomes S tends to ASA or AB or A or B. Why this A means why we get the A means in the place of this B I substitute epsilon, then I derived A. So I am taking the another rule as an A for this S, right? So A tends to epsilon, A tends to epsilon, B tends to B. And here up to now we remove only the B tends to epsilon. Now we will remove A tends to epsilon. And check it out where we are having the A tends to S. Where we are having the A tends to epsilon as a rule, and we need to check it out where the A is the where the variable A in another production. See here I'm having A, here I'm having two A's. So in the place of this two A's, if I substitute epsilon in the place of this A, then I get SA. If I substitute epsilon in this place of A, I get AS. So what the production is now, S tends to ASA or AB or B or A, right? Along with this, you need to take the other two after removing the A tends to epsilon. Either it may be AS or SA. See here, AS or SA, right? If you put the epsilon in the two A's, then you get S. So it is S. It is S, comma. A tends to B. B is having another rule also with a terminal B. So I need to continue with A tends to B. So A tends to B or B. A tends to B or B. Or directly B is giving B. Right? Is it clear? And in such a way, by applying all the three steps, you need to get the reduced grammar. This is a reduced grammar. By reducing the nullables, the final production set without null production is without null production is, this is the grammar, this is the finalized grammar that we're having here. S tends to ASA or AB or B or A or SA or AS or S. For A tends to B, or if I put an B in the place of this B, then it becomes B. Only what the thing I need to do is I need to eliminate the epsilons. So directly here I'm eliminating the epsilon. So my production does not my productions in the modified grammar does not consisting of the epsilon moves. So this is the modified grammar where I reduced the nullable productions. Is it clear? And this is the way of eliminating the nullables. And now Coming to the exercise problem, please make a note of this exercise problem, all of you, and consider the grammar G whose productions are S tends to AS or AB, or A tends to A, B tends to A, D tends to B. What the thing you need to do is you need to construct an G1. G1 is nothing but a modified grammar from the G. That means the equivalent grammar from the is an G dash, or you can take it as a G1 or G2, whatever it may be. G1 is an equivalent grammar from the G, and here my G1 does not consisting of any null productions. I need to generate an L of Z is equal to A, right? So this is the problem, exercise problem. Please make a note of this exercise problem and remove all the nullable productions. And what the nullable productions that we are having here, and please check it out, and whether the grammar is having the nullable productions, please remove all those. I think it is an, this is not an A, this is a null epsilon. A tends to epsilon, B tends to epsilon, these two are the nullables. Make a note of this. S tends to AS or AB, A tends to epsilon, B tends to epsilon, D tends to B. And then after, by noting down the given grammar, then you need to construct the grammar G1 without null productions, generating L of G is equal to epsilon, right? Without epsilon, you need to construct the grammar. So please make a note of this example. A tends to epsilon and B tends to epsilon, these are the two epsilons, nullables. Epsilon production representations. Please make a note of this example. And up to now, I think you understand how to remove or how to reduce or how to simplify the nullable productions, right? If the grammar is consisting of a null epsilons, then how to remove those epsilons in a three-step manner. I think you all understand that procedure, and make a note of this example. Then please do practice by taking this example. And with the practice only, you can get to understand how to reduce the nullable productions. And then the next concept is about removal of unit productions. Removal of unit productions. And here you are removing the unit productions. Unit productions means, first of all, you need to know how the unit productions are to be represented. That means any production rule in the form of like this, variable tends to variable, variable tends to variable, where A and B belongs to the variables, then we can call it them as an unit production. Simply we can call it as an unit productions. That means any production rule in the form of A tends to B, where A and B are the non-terminals, then it can be called it as an unit productions, right? So how to remove these unit productions? Here also we're having some three steps, and let's see what the step number one is. And the step number one is, first of all, you need to remove the unit productions, and you need to check it out where the where we're having the unit productions in the given grammar. And if the in the grammar, if the productions map with the syntax of the unit productions, then you need to remove those, right? So to remove A tends to B, and A production is having the rule like an A tends to X, A is having another rule to the grammar rule, where whenever B is having another rule, so it occurs in the grammar. So the X belongs to the terminal and X can be a null. X belongs to terminal and X can be a null. And the step number two is you need to delete A tends to B from the grammar. So for deleting this, you need to repeat the step number one until all the unit productions are removed, right? And now let's see with an example, then you can clearly understand what the three-step procedure is. And this is a problem, and what the problem is here, you need to remove the unit productions from the following. And what the grammar is, S tends to xy, where x tends to a, y tends to z or b, z tends to m tends to n tends to a. And before seeing this grammar, first what the thing is, you need to remember what the syntax of the unit productions are. Variable tends to variable one, always the left hand side should be in one variable, right? A tends to beta, in the format of A tends to beta, always the beta should be an variable, a single variable, then we can say that it is an unit production like this. So now there are three unit productions in the grammar, and what the three unit productions are: y tends to z, z tends to m tends to n. These are the three unit productions in the grammar. So at first you need to remove m tends to n. First of all, I am removing this m tends to n. And to remove this m tends to n, I need to know what the n is deriving. N is deriving in production A. So we need to add this m tends to A and m tends to n. Add m tends to A. That means what n is deriving? A. And now I am adding this A to the m, and I am eliminating m tends to n. Right? Is it clear now? And the production set becomes now s tends to xy, x tends to a, y tends to z or b, z tends to m tends to a, and n tends to a. Now here I'm not having an unit, right? So now remove this z tends to m. And before removing this z tends to m, you need to know what the m is deriving. M is deriving a, right? Then add that a to the z. Then remove z tends to m. Then what the productions are? Now it becomes s tends to xy, x tends to a, y tends to z or b. Now this z tends to a, m tends to a, and n tends to a. So z is deriving a, and m is deriving a, and n is deriving a. Right? So we're not having any units up to now. Now, what the third one? Now you need to remove y tends to z. Now for removing y tends to z, you need to know what the z is deriving. Z is deriving a, right? Then you need to add that a to the y. Then remove y tends to z. Now the set of rules becomes like the productions of the set becomes s tends to xy or x tends to a, y tends to a or b, z tends to a, m tends to a, n tends to a, right? And if you are having any doubt, here we're having two variables. If you have two variables, that does not comes under the unit productions. If you have only one variable at the right hand side of the production, then it becomes under the unit, right? So you need not take it as an unit, take under as an unit, right? So it does not becomes an unit only if you're having s tends to x means then it becomes unit, but here we're having s tends to xy, so that rule does not comes under the unit production. So with this, with the production set becomes now reduced unit productions. So now the z, m, and n are unreachables. So unreachables in the sense, what the x is deriving the two variables where those are x and y. But from the starting of the variable, starting of the symbol s, we're not having z, we're not having m, we're not having n, right? So if the rules are not derived from the starting symbol, if the variables are not derived from the starting symbol, then we can say that those are unreachable variables. So we can remove those variables also here. After removing the units, then finally you need to check it out which variables are unreachable variables, which productions are unreachable, and the productions that are derived from the starting variables itself, those are reachable. Otherwise the remaining all comes under the unreachable variables. So now the z, m, and n are unreachable, so we're removing those, and finally the context free grammar of the unit production becomes xy, x tends to a, y tends to a or b. So this is the very minimized grammar from the given grammar G. Minimize grammar, or we can say that it is a modified grammar G dash from the grammar G. I think you all understand how to remove the unit productions. In the last slide, I explained you how to remove the epsilon productions. And wherever you are seeing an epsilon production, don't just remove those. Just don't remove the epsilons. And there we're having the steps to be followed. Just follow those steps. And wherever it is necessary, you need to substitute the variable of the derived epsilon in that place, and then finally you need to eliminate the epsilon productions. Up to that you need not eliminate that, right? So here also, whenever we are eliminating the units, before that you need to do three-step procedure, and after that finally you will get the equivalent grammar G dash from the G, right? Is it clear? Any doubts to anyone? I think you all understand the two ways of eliminating or reducing or simplifying the context free grammar. One is by removing null productions, that is an epsilon productions, and the second one is by removing the unit productions. And please make a note of this example. And this is example for eliminating the unit productions and get an equivalent grammar from the G. Make a note of this example, and please make a note of this example and do get the answer by your own, and remove the unit productions by your own just by understanding whatever the thing from the concept. And please don't leave it just by doing the practice and practice, then you will get it's very easier for you for better understanding of these concepts. Make a note of this example. And let's see the concept of how to simplify context free grammars. And here we're having three ways to simplify or clean and context free grammar. And how to clean these means, first of all, you need to eliminate the useless symbols and then simplify, then eliminate the epsilon productions and then simplify, then eliminate the unit productions. And here we're having a syntax for the syntax, in the sense you are having an uh, indication that if the production is in the form of like this, of course we can say that it is a syntax. And if the for production is in the form of like this, then you need to eliminate. If the production is in the form of like this, then you need to eliminate. That is production. In the production, the variable is giving a deriving an epsilon, means you need to eliminate. And if in the production, if an variable is deriving, then variable only one variable, means then it can be considered as an unit, then you need to eliminate, right? And how we can know how to eliminate the useless symbols, the two concepts I already explained you. the elimination of epsilon productions and the elimination of unit productions. Elimination of epsilon productions can also be called as an reducing of nullable productions. Epsilons can be called as an nullables. So that concept I explained you, and I explained you with the procedure, a three-step procedure. Same as for the unit productions also, I explained you with an three-step procedure. Now to clean the context free grammar, how to eliminate the useless symbols, and that's the concept that we're having here for eliminating and useless symbols. See, for that, how to know what the useless symbols are and how to identify the useless symbols in the given grammar. So a symbol x is reachable if there exists a production like s tends to alpha x beta, right? So if a symbol x is generating, if there exists x tends to some string, for some string which belongs to the terminal, right? Or else for a symbol x to be useful, when it has to be both the reachable and the generating. That means if x is generating a string, or if x is a reachable variable, then we can say that it is an useful symbol. It is an useful symbol. What it means, and variable tends to, that is an s tends to alpha x beta, then it should also tends to the string. That means from the string we can generate an terminal for some string where it belongs to the terminal. Then that means here we're reaching and here we're generating. That means the variable that is unreachable as well as that it generates an terminals. So then we can say that it is an useful variables or useful symbols, right? And we know, up to now we know what, how, what are the useful variables are. And if it is in vice versa, if it is not a reachable variable and if we are not generating the terminal from that variable, then automatically that is an useless symbols, right? So if you know what the useful variables or useful symbols means, then easily you can understand what the useless symbols are. And here we're having an algorithm for detecting the useless symbols. And in that algorithm, what the first thing we need to do is we need to first eliminate the all the symbols. We need to first eliminate all the symbols that are not generating. That are not generating means, first of all we need to check it out which rule is going to be generate the strings and which rules are not going to be generate the strings. Right. First we need to eliminate those. And then after that we need to check it out, how to eliminate all the symbols that are not reachable. Right, reachable in the sense from the starting state to ending state. That means I need to generate an final state to accept the strings, right? So I need to check it out for that. And after checking out, I need to eliminate all the symbols that are not reachables. So what the thing I need to do here is, in the algorithm for detecting the useless symbols, I need to do two steps. Which symbols are not generating and which symbols are not reachable. So is the order of these steps important, or we switch? Let's see. This is an example of the useless symbol, right? And in this example, the productions are S tends to A, B or A tends to B. And this is a given grammar G. This is a grammar G. From this grammar G, A and S are generating. How I can say that A and S are generating means, S is directly producing a terminal. A is directly producing a terminal, right? But B is not generating. Why? To produce and B, I am not having the rule, I am not having the production for the B variable. So B is not generating, and therefore we can say that B is an useless. I think you all understand. S is directly giving an terminal A. A is directly giving an terminal B. And if I put the A tends to be in the place of this A is deriving the terminal. But in the place of this B, which rule I need to substitute? Which production I need to substitute here? Nothing is there, because I'm not having any productions for the B in the given grammar. So then automatically I can't generate anything from the B. So then the B becomes useless. Now I can eliminate B, right? And how to eliminate the B means, directly I can eliminate the B where this rule, because I can't take only A from this, because A is merged with an B. I can't separate this A and B. So directly I am eliminating this rule, right? So then my rules are S tends to A and A tends to B. So now S is reachable, but A is not reachable. Why A is not reachable? A is not from the starting of the symbol itself. That means that A we are not taking from the starting. A is not derived from the starting symbol S. So S is not reachable. Only sorry, A is not reachable. Only S is an reachable symbol, reachable variable. So now A is not reachable and therefore A is useless. And then the simplified grammar is S tends to A. See, from this grammar, finally what the grammar I get after eliminating the useless symbols, S tends to A. What would happen if you reverse the order? That means the test reachability before generating will fail to remove A tends to B. Right. So, and this is an example for useless symbol. Please make a note of this example. I think you all understand how to remove the useless symbols also. And up to now I explained you the three ways of reducing the context free grammars. One, by removing null productions, that is an epsilon productions, and two, by removing the unit productions, and the three, by removing the useless symbols. Please make a note of this example. And then in the next class I'm going to explain how to remove all these three altogether, removing all these three altogether. In the next class I will explain you the concept of removing all the three altogether. And please make a note of this example in this class. And whatever the exercise problems I gave in the previous slides for the null productions as well as for the unit productions, please do practice for those. And make a note of this example also for useless symbols. It is very easy for you. Just you need to check it out, which symbols are generating symbols, or which variables are generating variables, or which variables are reachable variables. Then if you know which are not generating, which are not reachable, then you need to eliminate those. Just eliminate those, and finally you need to write the simplified grammar like this. And if you well practice of these three ways of removing the context free grammars, means whenever I'm explaining you altogether removing these three, reducing nullable productions as well as units as well as the useless symbols, then it is very easy for you for understanding at a time of learning the three. And up to now I individually explain how to remove the useless, how to remove the units, and how to remove the nullables, right? So if you do practice, means then it is very easy for you when we are learning the concept of removing all the all together.